Once upon a time, in a quiet fishing village, there lived a fisherman called Oliver. Every morning he set out to sea, hoping to catch a bountiful catch for his family. Oliver started keeping track of the number of fish he caught each day. To his surprise, it seemed to follow a definite pattern. Oliver started learning probability and statistics. He realized that the number of fish he caught each day followed Poisson distribution. So what is Poisson distribution? It is the limiting form of binomial distribution. And what is the probability distribution for a binomial distribution? You have learned that for a binomial distribution, the probability of n successes in n trials is given by px, which is ncx p raised to x q raised to n minus x. The only difference is for a Poisson distribution, n is very large and p is very small. So np tends to a constant. And let np be equal to m. So what is q raised to n? Q is 1 minus p raised to n, but p is m by n. So it is 1 minus m by n raised to n, and we are just going to write this as minus n by m raised to minus n. So what happens here? The minus sign and the m cancels and it comes back to n. Now if you put minus m by n as k, q raised to n becomes 1 plus k whole raised to 1 by k raised to minus m. And 1 plus k raised to 1 by k is basically e. And if I put this as minus m, e raised to minus m, what happens to this as m tends to infinity, it tends to 0. So we know that limit as k tending to 0, 1 plus k whole raised to 1 by k is e. That is how we are writing this as e. So coming back to q raised to x becomes 1 minus p raised to x, and this tends to 1 as p tends to 0 for a fixed x. So px is ncx p raised to x q raised to n minus x. What is this? This is the probability distribution for a binomial distribution. And ncx is n into n minus 1 into n minus 2 into n minus x minus 1 by x factorial p raised to x into q raised to n minus x. Now what are we going to do here? I'm taking out n from each term. There are x terms, so it is n raised to x, 1 minus 1 by n, 1 minus 2 by n, 1 minus x minus 1 by n, p raised to x, q raised to n minus x by x factorial. Can we take both these x's raised to exponents together? Yes. So this is np raised to x, 1 minus 1 by n into 1 minus 2 by n into 1 minus x by x minus 1 by n raised to n. Q raised to n minus x I'll write as q raised to n by q raised to x by x factorial. So this becomes, if I put np as m raised to x, e raised to minus m by x factorial. And this is the probability distribution for a Poisson distribution. All these terms tend to 0 as n tends to infinity. So px is called the Poisson distribution function and x is the Poisson variate. So we have values here for x equal to 0, px is e raised to minus m. If I put x equal to 1, p1 becomes m e raised to minus m by 1 factorial. If I put x equal to 2, it becomes m squared e raised to minus m by 2 factorial. So summation x taking value 0 to infinity px becomes e raised to minus m plus m e raised to minus m by 1 factorial plus m squared e raised to minus m by 2 factorial. Can we take out e raised to minus m common? Yes. So it becomes e raised to minus m into 1 plus m by 1 factorial plus m squared by 2 factorial and so on. This is nothing but e raised to m. So it is e raised to minus m into e raised to m, which is 1. So summation px is 1. Now what is the mean? Mean mu is given by summation x px. That is summation x equal to 0 to infinity x. Px is, what is px? M raised to x e raised to minus m by x factorial. So this is, if I take this as m raised to x and this becomes x minus 1 factorial, x by x factorial. So this becomes summation x equal to 1 to infinity. M raised to x e raised to minus m by x minus 1 factorial. So your mu is m e raised to minus m, summation x equal to 1 to infinity, m raised to x minus 1 by x minus 1 factorial. I am taking out m and e raised to minus m. So this becomes m e raised to minus m. When you expand this, what do you get? When x equal to 1, you get 1, plus when x equal to 2, m by 1 factorial, plus m squared by 2 factorial, and so on. So this is m e raised to minus m into e raised to m, which is m. What about the variance? Variance is summation x equal to 0 to infinity x squared px minus mu squared. What is summation x squared px? X squared, how can I write it as x squared minus x plus x? So this is summation x equal to 0 to infinity x into x minus 1 m raised to minus x e raised to minus m by x factorial plus summation x equal to 0 to infinity x into m raised to x e raised to minus m by x factorial. I am splitting this. Now what is this? If the x and x minus 1 cancels, and this becomes x minus 2 factorial, and the summation becomes summation x equal to 2 to infinity m raised to x e raised to minus m by x minus 2 factorial, and here the x and x factorial cancel, so you get x minus 1 factorial, and this is summation x equal to 1 to infinity m raised to x e raised to minus m. So this becomes m squared e raised to minus m. If I take out m squared and e raised to minus m, what will this power of m be? Mx raised to n minus m raised to x minus 2 by x minus 2 factorial. This is nothing but the Poisson distribution, which is m. So this is m squared e raised to minus m. Again this is e raised to m and plus m. So you get it as m squared plus m. What happens here? E raised to minus m cancels with e raised to m. So substituting, this is summation x squared px. So variance is summation x squared px minus what? Mu squared. But mu is m squared. So this becomes m. So standard deviation is root m. So what is the mean and variance for a Poisson distribution? Mean is m and standard deviation is root m. Coming to problems, fit a Poisson distribution for the following data and calculate the theoretical frequencies. So you have x and f. So summation fx by summation f, if you calculate and multiply, you get summation fx as 100. And if you add the summation f, what do you get? 200. So this becomes 0.5, which is mu. So your mu is 0.5. So the Poisson distribution becomes px equal to m raised to minus x e raised to minus m by x factorial. What is this? The probability distribution for a Poisson distribution. But here m is 0.5, so it becomes 0.5 raised to x e raised to minus 0.5 by x factorial. And if you have to put f, so f of x will be 200 because summation f is 200. So f of x will be 200 px. That is 200 into 0.5 raised to x e raised to minus 0.5 by x factorial. Now, in a certain factory, this is the next question, turning out tools. The probability of any tool to be defective is 1 by 500. The tools are supplied in packets of 10, so we have packets of 10. Use Poisson distribution to calculate the approximate number of packets containing no defective tools. So probability of a defective tool is 1 by 500, that is given to you, and mean is NP. N is 10 here, so 10 into 1 by 500, that is 1 by 50, which is 0.02. Poisson distribution is given by Px equal to m raised to x e raised to minus m by x factorial. What is m here? 0.2. So it is 0.2 raised to x e raised to minus 0.02 by x factorial. I am substituting m as 0.2. Now, when there is totally you are given that 10,000 packets are there. So f of x will be 10,000 px. So we multiply this by 10,000, that is 10,000 into 0.02 raised to x by x factorial. Now e raised to minus 0.02, you can calculate it is 0.9802. So what are we doing here? We are substituting for e raised to minus 0.02. So number of packets with no defective tool is put x as 0. So you get f of 0 is 10,000 into 0.9802, which is 9,802. Number of packets with one defective tool will be what? Put x as 1. So you get 10,000 0.02 into 0.9802, that is 196. And what will be the number of packets with two defective tools? Put x as 2 here. So you get 10,000 into 0.02 squared by 2 factorial into 0.9802, and this gives you the answer as 2. Coming to the next question. The number of accidents in a year to drivers in a city follows a Poisson distribution with mean 3. Out of 1,000 drivers, find approximately the number of drivers with no accident in a year. That's the first part. What is the mean here? Mean is 3. So px is m raised to x e raised to minus m by x factorial. That is m raised to x e raised to minus 3 by x factorial. You have 1,000 drivers. So fx will be 1,000 px. So number of drivers with no accident will be what? Put x as 0. So you get 1,000 into p0, that is 1,000 into m raised to 0 e raised to minus 3. What is 0 factorial? It is 1. So 1,000 into e raised to minus 3 is 50. And number of drivers with more than 3 accidents in a year will be 1 minus number of drivers with less than or equal to 3 accidents. So this will be 1 minus e raised to minus 3 p0. E raised to minus 3 raised to 0 by 0 factorial. What is p1? E raised to minus 3 raised to 1 by 1 factorial. Plus p2 e raised to minus 3 squared by 2 factorial. And p3 will be e raised to minus 3 cubed by 3 factorial. Simplifying, you get it as 0.35. So number of drivers with more than 3 accidents in a year will be 1,000 into, what is this? This is p3. Greater than or equal, greater than 3. So 1,000 into 0.35, that is 350. So with this knowledge of Poisson distribution, Oliver could make uniform predictions about his daily catch. Soon other fishermen sought his advice, and the village flourished as other fishermen optimized their strategies based on Poisson distribution. So thank you, and do subscribe to my channel.